Hello basic calculus students. This video is the continuation of our discussion about the continuity of a function. Suppose we are not given the graph of the function, but just the function itself. How do we determine if the function is continuous at a given number? In this case, we have to check three conditions. Function f of x is said to be continuous at x equals c if the following three conditions are satisfied. First, f of c exists. Second, limit of f of x as x approaches c also exists. And third, f of c equals limit of f of x as x approaches c. Note, if at least one of the three conditions is not met, f is said to be discontinuous at x equals c. Example, determine if f of x equals x cubed plus x squared minus 2 is continuous or not at x equals 1. Solution. We have to check the three conditions of a function. First, if x is 1, f of 1 is 0. If limit of f of x as x approaches 1 is limit of f of x cubed plus x squared minus 2 as x approaches 1 equals limit of f of 1 cubed plus 1 squared minus 2 as x approaches 1 is 0. So for the third condition, since f of 1 is 0 and limit of f of x as x approaches 1 is also 0, then f of 1 is equal to limit of f of x as x approaches 1. Therefore, f is continuous at x equals 1. Another example, determine if f of x equals x squared minus x minus 2 all over x minus 2 is continuous or not at x equals 0. Solution, we have to check the three conditions of the function. If x is 0, then f of x is equal to 1. So we simply plug in 0 to x in the function. Limit of f of x as x approaches 0 is limit of f of x as x approaches 0 equals x minus quantity x minus 2 times the quantity x plus 1 all over x minus 2 equals limit of f of x equals x plus 1 as x approaches 0 is 1. Third condition, f of 0 is equal to limit of f of x as x approaches 0. So the three conditions are satisfied, so therefore f is continuous at x equals 0. Next example, determine if f of x equals x squared minus x minus 2 all over x minus 2 is continuous or not at x equals 2. Solution. Note that if is not defined at x is 2, since 2 is not in the domain of f. Hence, the first condition in the definition of a continuous function is not satisfied. Therefore, f is discontinuous at x equals 2. Balikan natin yung function. f of x equals x squared minus x minus 2 all over x minus 2. If we plug in 2 to x, we will have in the denominator 2 minus 2 equals 0. So we will have division by 0, which is undefined. So 2 is not in the domain of the function, and therefore the function is discontinuous at x equals 2. Another example, this is a piecewise function. Determine if f of x equals x plus 1 if x is less than 4. F of x equals the quantity x minus 4 squared plus 3 if x is greater than or equal to 4. Is continuous or not at x equals 4. Solution. Note that f is defined at x is 4 since f of 4 is 3. However, limit of f of x as x approaches 4 from the left is 5, while limit of f of x as x approaches 4 from the right is 3. Therefore, limit of f of x as x approaches 4 does not exist, and if is discontinuous at x equals 4. Let me elaborate the solution. Tingnan natin ito. Limit of f of x as x approaches 4 from the left is 5. Okay, if we approach x from the left of 4, ang value ng x dito ay less than 4. So, pwedeng 3.5, 3.7, 3.8, 3.999. Since less than 4, ang value ng x dito siya papasok. X is less than 4. So, ang gagamitin nating function ay f of x equals x plus 1. So, this would be 4 plus 1, 5. For this one, if we approach 4 from the right, okay, so ang value ng x dito ay pwedeng 4.5, 4.2, 4.1, 4.999. So, ang value ng x dito ay greater than 4. So, dito siya papasok. X is greater than or equal to 4. So, ang function na gagamitin natin ay ito. F of x is the quantity x minus 4 squared plus 3. So, 4 minus 4 is 0 squared. 0 squared is 0 plus 3. So, the limit of the function is 3. So, since magkaiba yung value na ina-approach ng function, as we approach 4 from the left and from the right, sa discussion natin ng limits, ang sabi natin, pag ganito ang case, limit does not exist. So, the second condition is not satisfied in the three conditions for continuity. Therefore, f is discontinuous at x equals 4. Now, let's have the continuity on an interval. A function can be continuous on an interval. This simply means that it is continuous at every point on the interval. Equivalently, if we are to draw the entire graph of the function on an interval without lifting our tracing pen or without being interrupted by a hole in the middle of the graph, then we can conclude that the function is continuous on that interval. We begin our discussion with two concepts which are important in determining whether a function is continuous at the endpoints of closed intervals. So we have one-sided continuity. A function f is said to be continuous from the left at x equals c if f of c equals limit of f of x as x approaches c from the left. A function f is said to be continuous from the right at x equals c if f of c equals limit of f of x as x approaches c from the right. Here are known facts on continuities of functions on interval, continuity of polynomial, absolute value, rational, and square root functions. A polynomial functions are continuous everywhere. The absolute value function f of x equals the absolute value of x is continuous everywhere. Rational functions are continuous on their respective domains. The square root functions f of x equals square root of x is continuous on the interval, this interval. Pag nakita nyo itong symbol, ibig sabihin yung point, yung 0 is included. Pag ganito naman, close parenthesis, hindi included. Example, consider the graph of the function f given below. Using the given graph, determine if the function f is continuous on the following interval: a, -1, 1, b, -infinity, 0, c, 0 to positive infinity. Solution. Remember that when we say trace from the right side of x equals c, we are tracing not from x equals c on the x-axis, but from the point z f of c along the graph. So for letter A, we can trace the graph from the right side of x is -1 to the left side of x is +1 without lifting the pen we are using. Hence, we can say that the function f is continuous on the interval -1, 1. Let's take a look at the graph of the function. Here is -1 and here is +1. So we are considering the portion of the graph from here up to this point. So as you can see, we can trace the graph on this particular interval without lifting our pen. So wala tayo nakikitang butas dito or hole sa graph. So the function is continuous on that particular interval. For letter B, if we trace the graph from any negatively large number up to the left side of 0, we will not lift our pen, and so f is continuous on -1, 0. Okay, -1 to 0, galing dito, papunta doon. Okay, so wala din hole, so continue siya dyan. Letter C, for the interval 0, positive infinity, we trace the graph from the right side of 0 to any larger number and find that we will not lift our pen. Thus, the function is continuous on 0, +1. Example 2, determine using the given graph if the function h is continuous on the following interval: a, -1, 1, b, including 0.5 to 2, including 2. Solution. Because we are already